Hey Christina, here's the problem that you were looking at. If my original function is x squared over 6 plus x, it looks like I have a variable at the top and a variable at the bottom. I don't think I can reduce anymore, so to me this looks like a quotient rule. So I'm going to find the first derivative by using quotient rule, which is the bottom times the derivative of the top minus the top times the derivative of the bottom, and the derivative of 6 plus 1x is just a 1, all over the bottom squared. I'm going to simplify this by distributing through the 2x. 6 times 2x is 12x, 2x times x is 2x squared, and then I have the negative x squared times 1, which is a negative x squared, all over my denominator of 6 plus x squared. When I combine my like terms, I end up getting 1x squared plus 12x over 6 plus x squared. So this is my first derivative. And they're asking us to find the second derivative, right? So now I need to find the derivative of this. So again, I see variables at the top and variables at the bottom being divided, and I can't simplify it anymore before I start, so I'm going to use quotient rule again. But I also noticed that this has a quantity, has stuff inside raised to a power, so I'm actually going to be using quotient rule and chain rule at the same time. So here we go. Starting with quotient rule, I have the bottom times the derivative of the top minus the top times the derivative of the bottom, and this is where we're going to use chain rule. We're going to bring the 2 forward, we're going to keep the inside the same, we're going to subtract 1 from the exponent, so my new exponent is a 1, and then I'm going to multiply by the derivative of the inside, so again the derivative of 6 plus 1x is just a 1. That's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And so since it was squared and I'm going to square it again, I really multiply the exponent, so I would really get the 6 plus x to the 4th power. Now what I'm going to do here is I'm going to try to simplify that numerator. I notice that there is a big old term here and a big old term here, and they both have at least one 6 plus x in them. You could FOIL everything out. It would take you a while, so just be careful with your time on that. And then you can combine like terms there, or you can look for a GCF. And to me, a GCF is a little bit easier because then I don't have to FOIL and I don't have to make mistakes by doing all of those steps. So when I take out the GCF of the 6 plus x, I'm going to leave all my leftovers. If I take out one 6 plus x, then I have 1 left because there was originally 2 of them, right? I also have this 2x plus 12 left. If I took out the 6 plus x in this term, then I still have a 2 times a 1, which is just 2. I have a negative, so I can really say negative 2. And I have this quantity of the x squared plus 12x. So this is all my leftovers. I'm going to go ahead and simplify those leftovers by FOILing or distributing through all of the pieces. When I do that, I ended up with a 12x, what is that, plus 72 plus 2x squared plus 12x minus 2x squared minus 24x. Looking at my terms, I have a positive 2x, let me use a different color, positive 2x squared and a negative 2x squared, they cancel. I have a positive 12, that's a positive 24x. With the negative 24x, those all cancel. And so it looks like in this second derivative, I have the 6 plus x, my GCF, and then I have a times 72. All my leftovers canceled except for that 72. Over the denominator, which was the 6 plus x to the 4th power. And if you notice, I have a factor from the top that's the same as a factor from the bottom. So I can reduce a 6 plus x from the top and the bottom. That would leave me with a second derivative of just a 72 on the top and then a 6 plus x cubed on the bottom.